Welcome to Lecture 2.1, The Meaning and Properties of Fractions. So there's a problem in our book that I kind of want to go over really quickly. And if you consider receiving a medical test which involves you having contact with radioactive iodine-131, all radioactive elements decay naturally. The half-life of iodine-131 is 8 days, meaning every 8 days, the sample of iodine will decrease to half its original amount. So let's take a look at a table and a chart. So let's say the 0th day since you were exposed, you have 100% of the dose remaining. You have the whole dose remaining. After 8 days, you only have half the dose. After 16 days, you have 1/4 of the original dose. After 24 days, you have 1/8. After 32 days, you have 1/16th, pardon me. After 40 days, you have 1/32nd of the original fraction of the dose remaining. So you see, you start off with the full amount and then it decreases rapidly and then starts slowing down, but eventually it will get to 0. And this is with everything in life that is natural. It does have a half-life. So why do we bring this up? Because we're starting to talk about fractions. And the definition for fractions is any number that can be put into the form a over b, where a and b are numbers and b is not 0. It's very important that b is not 0. Here's some examples. 1 over 2 is also called 1/2. 3 over 4 is 3/4. 7 over 8 is 7/8. And 9 over 5 is 9/5. Now, if we want to take a look at what it is to be 1/2 of something, so we're going to visualize it. Here I have a rectangle and I have shaded half of the rectangle. This is 1/2. Out of the 2 spots, one is shaded 1/2. Here, my rectangle is divided into 4 sections and I've still shaded in half of my shape. But in this case, I've shaded 2 of the 4, so it's 2/4. Again, it's still 1/2 of the full shape. Here I have 8 spots, and I've shaded half of them, which is 4, so it would be 4/8. Again, it's still 1/2. And here is a rectangle that I have 6 squares, and I have shaded half of them, or 3 of the 6. And it's still 1/2. I'm going to throw a lot of vocabulary at you, so let's start with the numerator. The numerator for a fraction a over b is a. That's called the numerator. The top number is the numerator. The bottom number is the denominator. So the fraction a over b, b is the denominator. And you'll hear me say numerator and denominator frequently. So the numerator is on top and the denominator is on the bottom. So let's take this example and name the numerator and the denominator of each fraction. Let's see if you can do it. Go ahead and pause the video and give it a try. I'm going to run through them very quickly. 3, 9, and 7 are the numerators. 4, 5, and 1 are the denominators for each of the fractions. So again, we have some terminology. First is a proper fraction. A proper fraction is where the numerator, remember the numerator is the top number is less than the denominator. An improper fraction is a fraction whose numerator is greater or equal to the denominator. Let's look at some examples. So proper fraction would be 3/4, 1/8, 9/10. All the numerators, 3, 1, and 9, are smaller than the denominator, 4, 8, and 10, respectively. Improper fractions are any fraction that the numerator is greater than or equal to the denominator. So 9/5 is improper, 10 over 10 is improper, 6 is improper. But why is 6 improper? Because we can write it over 1. And of course 6 is larger than 1, so therefore it's an improper fraction. Let's take a look at what fractions look like on a number line. For example, if I have a number line, I start it with 0, and I break it into 1/3 portion, so 1/3, 1/3, 1/3. On the number line it would be 1/3, 2/3, and 3/3, which is also 1. And if I just break it apart with just 3/3, 2/3, and 1/3, you can see that it is a shorter length that we're applying to our number line. Now, let's take a look at a number line that I have numbered in a different way. So the first number line, I've divided it up into 3, so it's 1/3, 2/3, 3/3. The second number line, I've divided it up into 6, so it's 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. And the last one, I've divided it up into 12ths. So it's 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, and 12/12. The reason why I've gone through this is to show you that on the number line, if we line these up, 1/3, 2 6ths, and 4/12 all line up directly above each other. In other words, it's just another way of writing 1/3 is 2 6. Another way of writing 2 6 is 4/12. Likewise with 2/3, 4 6, and 8/12. And of course, 3/3, 6 6, and 12/12 are all equal to 1. They are called equivalent fractions. It means that fractions represent the same number. For example, the 3 over 3, the 6 over 6, and the 12 over 12, they all equal 1. So here's some information that we need to know. If A, B, and C are numbers, and B and C are not 0, then it's always true that A over B equals A times C over B times C. That's exactly the type of problem that we have up here. 1/3 equals 2 6 if I multiply both the numerator and the denominator by 2. Likewise, 2 6 equals 4/12 if I multiply the numerator and the denominator by 2. I'll get to the next step. So if I want to write 3/4 as an equivalent fraction with the denominator of 20, I have to multiply both the top and the bottom, the numerator and the denominator, by 5. So 4 times 5 gives me the 20 for the denominator, and 3 times 5 gives me 15, so the answer is 15/20. Now let's try another problem. Let's write 3/4 as an equivalent fraction with the denominator of 12x. What do I have to multiply for to get to 12x? I have to multiply it by 3x, and whatever I multiply on the denominator, I must multiply by the numerator. If I multiply both numerator and denominator by 3x, 4 times 3x is 12x, and 3 times 3x is 9x. So 3/4, the equivalent fraction with the denominator of 12x, is 9x over 12x. Likewise, if it's true about multiplying by the same number, you can also divide by the same number. So if a, b, and c are integers and b and c do not equal 0, then a over b equals a divided by c over b divided by c. I want to write 10/12 as an equivalent fraction with the denominator of 6. To get to 6 from 12, I have to divide by 2. And what I do to the denominator, I must do to the numerator. So 12 divided by 2 is the 6. 10 divided by 2 is 5. Now, we have a couple of rules. If a is any integer, then a over 1 is a for any a, including 0. And a over a equals 1 for any a except for a equals 0. So 3 over 3 is 1, 12 over 12 is 1, 100 over 100 is 1. Anything over itself is 1, or is equivalent to 1, I should say. Now let's take these examples and simplify each expression. So 24 over 1 can just be written as 24. 24 over 24 is 1. Remember, anything over itself is 1. 48 over 24. Well, 24 times 2 gives us 48. So this reduces down to 48 over 24. Reduces down, simplifies to 2. 72 over 24. That simplifies down to, this is 24 times 3 over 24. This simplifies to 3. And that's the last part of our Part 1 of Lecture 2.1. Stay tuned for Part 2. Until then, be seeing you.